project presentation. Thanks for coming. And this semester we have only one project, and these four guys did such a great job. Honestly, please stop by after the presentation, look at the quality of their work and the way they present their project. They worked a lot. They did a lot. And I think each and every one of them deserve an A, but I'm not going to give it to them now. I gave them a hard time, but we came a long way. And honestly, I'm very proud of the project because at the age they are, where they are, senior, and doing such a nice job before they go out of the college and get into workforce. It's a beautiful job. When I compare myself to them, I don't think I did anything close to this a long time ago. Okay? So, go ahead and thank you for coming.
All right. First off, thank you guys for coming to watch this presentation. We really appreciate it. My name is Jeff Gerspot. This is Jacob DeWoody, Albert Dudupong, and Andrew Danster. And we are Good Engineering, where the name is good, but the service is great. For our senior project, we decided to demolish the existing CET building and the two labs out back and combine it into one building. And here is shown a rendering of our building. This will be a parking lot up here. Albert will tell you in a few minutes more about that. The existing conditions we have right now is the main classroom and offices at 13,800 square feet. The soils and concrete lab at 2,000 square feet. And the competition and special projects lab at 11,000 square feet. The inspiration for the design of our building came from the architecture building and the engineering buildings on campus. We wanted to use the glass walls. We thought it looked good. Here's a simple rendering of our proposed building. This is a view from the upper parking lot up there. And this would be the front of the building right here with the classrooms and offices. And you see on the two sides, on one side we have a staircase, and on the other side is an elevator to take you down to the second floor. Here's a view from the opposite side, which would be from the lower parking lot. And you can see here on the lower floor, we have all of our lab spaces with garage door openings. And on the second floor, we have 3 accessible balconies from the classrooms and offices. And you can see right here, we have a little tower with glass walls to let some light in. And now I'm going to pass it off to Jacob, who's going to tell you a little bit more about the existing conditions.
All right, here you can see the issues that we recognized when we started this project. The main problem we found was the low profile of the existing building. Additionally, you can see the insufficient parking for the lower parking area here. Inconvenient access from the upper parking, which is this parking area right here. And then just some general drainage issues. All right. Here you can see an image of the architecture building across the street from the CET building. And you can tell it's just a large, beautiful structure that you can see from a distance. And then here you can see the CET building from the architecture building. And it's almost camouflaged into the trees. It's just an outdated building that needs to be updated. And then this is a representation of the insufficient parking. There's only 27 spaces down in this lower area. And in a bit, Albert's going to tell you a little bit more about how we plan to expand that parking area. All right, and here you can see a couple of footpaths cut into the side of the hill here that separates this upper parking area from the CET buildings. And that just creates very inconvenient access from that upper parking area. And numerous times you'll see students walking around campus with a red streak down the side of their pants from having fallen down that hill. So it's also a safety hazard. And then finally you can see this one little drainage structure serves this whole area here. And we actually had to clean out that grate quite a bit when we took this picture. So it clearly needed to be upgraded. And at this point I'm going to turn it over to Albert. He's going to explain a little bit more about these proposed improvements.
As you can see, we are demolishing the CET building and then building up instead of building up. So we're providing 2 levels. One level coming in from the upper parking lot, another level coming in from the lower parking. And then we'll increase accessibility, and then we'll create more access to the building. We accomplish this by implementing a retaining wall between the building and the higher parking, so as to allow us to build and allow good access. And then as you can see, we will demolish all the current CET building and provide space for all what we had before. And then we also will have to take care of some drainage issues. Like he was saying, all we had before was just one outlet there, but we're providing 2 outlets to take care of the drainage coming this way. And in addition, we're increasing the parking spaces from 27 spaces to 54 spaces. And then we're utilizing the Cobb County standard details to accomplish all our goals. And I will leave it to Andrew to give you the structural aspect of our design.
Thanks, Albert. All right, for the structural design, you can see here we got nice elevation views, street views of the building we've got. You can see from the lower level and the upper level here. And now, for the design of the structure, we used the International Building Code of 2012. We used an Excel workbook that gave us all our dead loads and twin loads as we implemented the correct inputs for the building. And then I used a design software called Enercalc to ensure we got the right design loads implemented on the beams and columns and foundation. Just like any structure, you have a foundation, and that's supporting the steel columns and beams, which support your elevated floor and roof. All right, and then at the top here you can see our basic foundation plan. It's pretty simple, slab on grade, and then at the columns, each column in the bottom left, you can see an example of a pad footing and an isolation joint to prevent any cracking due to the point load at those locations. Really the hardest part of the foundation design was the retaining wall, which allowed us to build the structure right on the hill and give us that ease of access to both sides, from both sides of the building, both parking lots. All right, and then for the elevated floor, we had bar joists, K-joists, framing into our beams and columns, and then that supported a 1-inch C-deck, which supported a 4-inch concrete slab for the main portion of the floor. And then at the 2 towers, we used a 3-inch VLI composite deck with the concrete to span between those shorter sections of those walkways. And then for the roof, again, we used bar joists. This time it supported just 1.5-inch E-deck, roof deck for the main expanse of the roof. And then at the towers, we used CFS trusses to cap off the towers. And then around the exterior perimeter edge of the roof, we have a parapet to hide any mechanical units and finish off the structure nicely since it's a flat roof. And now I'm going to turn it over to Jeff, who's going to go over a quick project cost analysis of the structure.
This bar graph right here shows you a little bit of how we are increasing the size of our building. The total building size will be increased by 15,600 square feet. And the classrooms and offices, we're increasing it by 12,000 square feet, and the labs by 3,500 square feet. For the cost of the building, we use the RS Means Building and Construction Cost Data of 2014. And for the classroom portion, we got $4.2 million. And for the lab portion, we got $4.3 million, bringing the total cost of this project to about $8.6 million. And special thanks to Professor Misbaki for guiding us through this project, and for the Cobb County GIS for providing us with some information. Any questions?
So this new building would be sort of like, what you were saying is like kind of flush to this hill up here?
You know where the two
Okay.
walkways are down the hill? It'd be right up against that wall, or right up against the hill.
So like how would the building like access those parking lots, just like via stairs or?
Well, you see right here on the left side, this is a stairwell
Yeah.
that goes up, and on the right side's an elevator. It'll
Oh,
take you up to the upper level. And
Okay.
there's also an indoor stair.
So you can get to the second level from the upper parking lot
Yep,
and then take
correct.
the elevator down?
Yeah, and basically the parking lot up on the upper level is flush with the first ground level that we have, and then it'll go down into a basement level for this lower area.
Okay, all right. And you're demolishing also those competition labs over there, and then that's all kind of on that?
That'll be
Yeah.
included in the
Yeah.
lab space.
Okay, all right.
Good question.
So how was the foundation system?
I'm sorry?
Single footings, the foundation?
Yeah.
Single footings, a mat foundation?
No, not mat foundation, it was basically just a 4-inch slab on grade for the main expanse, and then at each point load for the columns, we had pad footings. There's,
How large, how big the pad is?
I was using 3 KSF for the soil, I came up with like 6.5 feet for the foundation.
3 KSF for the,
Yeah.
you know that this area is fill area though, right? This building is sitting on a fill area.
We didn't know pretty much
But
anything.
you assumed 3 KSF?
Yeah, I just assumed 3 being kind of conservative
Okay.
with that. Usually that's pretty low as far as
Okay.
soil, I thought, so.
Any more questions? Well, thank you guys for coming by and listening to our presentation.
You're more than welcome to come by and look at their drawing, because their drawing is a whole lot more detailed. We try to fit it in 15 minutes, but it's such a beautiful project. Honestly, take a look at it. They have done such a great job.